So to show the influence of this amphoteric effect, what we can look at now is if we take a plot of the solubility on the y-axis and pH on our x-axis, and we look at a solid like AlOH3. So for aluminum hydroxide, our solubility plot is going to look something like this, where at a pH of 7, we have the least amount of solubility for this particular solid in solution. If we do the calculation, at a pH of 7, 1.1 times 10 to the minus 9 grams of aluminum hydroxide will dissolve in 4 milliliters of solution. At pHs that are very, very acidic, due to Le Chatelier's principle, we can say that this solubility down here is going to be 8.9 times 10 to the minus 2 grams in 4 milliliters of acidic solution. And this acidic solution would have a pH equal to 3. As we raise the pH, the solubility begins to drop off, which we would expect that from Le Chatelier's principle, because the equilibrium we're looking at is AlOH3 is a solid in equilibrium with aluminum 3 plus ions in solution plus 3 OH minus ions in solution. So as I increase the pH, we are increasing the concentration of the OH minus ions in solution. So as we increase that, we would expect the solubility to drop off. And that's what happens in this first case here, where the solubility drops. But then, as we keep increasing the pH even further, the solubility increases again. So in this portion of our solubility curve, there's going to be complex ion formation. And due to the complex ion formation, our solubility is 5.0 times 10 to the minus 3rd grams in 4 milliliters with a pH equal to around 12. So we can see that the solubility is going to be drastically influenced by our pH. And this type of a graph right here is something that you will see, and it's a classic case for an amphoteric cation in solution. In terms of looking for these amphoteric effects, the common amphoteric cations are the following: aluminum 3 plus, chromium 3 plus, zinc 2 plus, antimony 3 plus, and tin 2 plus. These are our common amphoteric cations that we see in solution, which are going to exhibit a solubility curve that looks like this. The non-amphoteric metal cations will just see a drop in solubility as the pH increases. So when you're doing problems, you want to look at cations. Look at one of these cations right here, and as you compare the KF tables, these are the most common cations in solution that form these complex ions.